Okay, welcome back. I'm your friend Inside XO. Here we will continue to nerd the Cocos 2D game engine. And to be specific, here we are going to read the documents of this one. Hello guys, welcome back. After I have seen a lot of materials on the document, I suddenly find that they are not actually using C++ to do the game development. They are using the JavaScript. They are using the JavaScript to do the stuff or to do the script. And what they are, how do they use it? How do they use it? Actually, they are using, let's say they are using a software which called Cocos Creator. It's kind of an IDE. And when you get there, you'll see a window like this or something like this. And when you get when you get into the IDE, you will see a screen like this. It's what the IDE looks like. Even it's also the same if you are using the Unity 3D. They are the same. But as I think Unity 3D would be more powerful than this, because this is mainly for the 2D stuff. But this software, it is also can be used to make some 3D games, but it's not that professional as the Unity 3D would give you. Okay, wait a minute. I suddenly found stuff. At the top of the document, actually you have a lot of choice. For example, you can choose the Cocos Creator. If you do that, you will have an IDE, and you will have to use JavaScript to do the game development. Or if you choose the Cocos 2D X, if you click that, and it will lend you to the C++ document of the Cocos 2D. And from this you can get started, and this is what we are looking for. So Cocos 2D-X, this is a game engine. Itself, it includes the engine and the Cocos command line tool, which we have already installed. Cocos Creator is a unified game development tool. You can create your entire game from start to finish using this tool. It uses JavaScript natively and can export to C++. Okay, and also we get something else there. Auto is used for creating local variables. Using namespace Cocos 2D, it's used to shorten types. No, I think it means to use the Cocos namespace. Use those functions under the namespace. Each chapter has a compilable source code sample to demonstrate concepts. Class names, methods names, and other API components are rendered using fixed fonts. Okay, why choose Cocos 2D-X? Why would you want to choose Cocos 2D-X over other available game engines? Because the first one, it has the modern C++ API, and it is cross-platform. We can compile to desktop or mobile device. A wide API of functionality, including sprites, actions, animations, particles, transitions, timers, events. For example, you can do some touch handling, keyboard handling, and so on. And it can play sound, read feel or write to feel. Learning resources. Okay. Basic Cocos 2D concepts. This chapter assumes you have just gotten started with Cocos 2D-X. Okay. The first one, director. You can think of the director the same way you think about a movie director. Yeah, that's what I was thinking about. The director controls every aspect of your game. What is shown on the screen, what sounds are played, what happens when a player do an import. Scene. A scene is a counter that holds spirits, labels, and nodes, and other objects that your game needs. A scene is responsible. A scene is responsible for running game logic and rendering the contents on the on each frame. Spirit. A spirit is a 2D image that can be animated or transferred by changing its properties. Most of the games will have multiple spirit objects ranging from the hero, an enemy, or a level boss. Scene graph. The scene graph is a data structure that arranges a graphical scene into a tree structure. This tree structure is what is used to render objects on screen in a specific order. Rendering. In an oversimplified definition, the rendering is responsible for taking everything you want on the screen and getting it there. Technically, no need to dive into this too deep at this time, because it's just a method to show those images to the screen. Events. What do you do when the player moves around? What about touch events or keyboard input? These are triggers, events that can be acted upon as needed. Audio. Perhaps your game has background music and or oh shit, this is a wrong sentence. For example, if you want to play some sound or music, you have to use this module or concept. UI components, things like button, label, scroll view, and so on, they are components, just like what you would say in the web development. Physics engine. The physics engine is responsible for emulating the laws of physical of physics. So this is let's think it as an simulation for the real world. Sometimes we would like to use that. For example, the gravity. Okay, let's start by doing. Let's build a game. We already have that from the previous video. We already created a new game. You know what? The YouTube is a good platform. Because only in this platform you would say you would have the chance to get a lot of knowledge, which is something that you cannot say normally on other platforms. Especially for those short video platforms, they are those videos in there. They are cheap and unhealthy for your life, to be honest. Okay, let's go on. The main components. It might seem overwhelming at the first, but getting started with Cocos 2D is simple. Before we dive into the deeps, we must understand some of the concepts this game engine has. At the heart of Cocos 2D are scene, node, spirit, menu, and action objects. Look at any of your favorite games and you will see all of those components in one. You would say they almost got all of those concepts inside that game. Let's have a look at this. I'm pretty sure the start game here, it is a menu. And there, the scores, and this, and the title, it is labels. And here we got the 3 characters. They are spirits. App delegate. App delegate is a very important class. App delegate is called once all the platform dependent code is run. The magic starts here. Let's take a look. I have no idea about that. But I think this code is something useful because we have to use this code to create a scene. Then we do the director run with this scene. For example, let's go to the classes. Oh, we already got the app delegate CPP file right in there. So let's have a look at this. First, it got 4 sizes, different resolutions. For this one, out of the initial function, we got nothing. Out of the de-initial function, we got the audio engine end function. And in here, application did finish launching. I think it's probably the same thing as the component did mount stuff. So actually what this function do is to create the game object or initialize the game object. Like first it creates a window like here, and then it creates then it gives that window to the director, and after that it creates a scene here from phone or game object hello world. Then it says director run with the scene. So that's how we say that scene, which is also how this code works out here. Making a few code changes so that we can get started making this game a bit more personal. We can change the title of the G view. This is a simple change made in the Apple delegate class. Take a look to the following lines. So it is different if the platform is a Windows platform or MSA or Linux. We create a window like this by giving the desired resolution. Else we just create a window, and in the end we give that window to our director. Director. Cocos 2D-X uses the concept of director. It's just like a movie. The director object controls the flow of operations and tells the necessary recipients what to do. Think of yourself as the executive producer, and you tell the director what to do. One common director task is to control scenes. Go from one scene to another. The director is a shared singleton. What is that? Effectively, there's only one instance of the class at a time, and you can run it or call it from anywhere in your code. Here is an example of a typical game flow. Intro, from the intro to menu, then from the menu to level 1. From the level 1 to level 2. If we passed that game, we go back to the scores or go back to the menu. How do I get the director's attention? To interact with the director, you need to call on it. There are a few ways to do this. Auto director equal to Cocos2D director get an instance. Director run with scene like that. From here, we can also say how they define the director. Okay, here we go. Director get an instance. Get the director for each operation. Cocos director get an instance. Get win sizes. Not recommended. So to be honest, you should get the director as a global variable. Then you use that global variable everywhere in your game. What scenes can the director do? It can do many stuff. For example, you can run with the scene used as when you start your game. Then you can use this class. I would like to say think it as a class or instance of a class. You can use it to replace your scene. For example, you can stop the animation and you can start it again. And you can set or get the properties of your game. For example, you can turn on or turn off the FPS label or calculation. And you can manually set the FPS, how many frames per second you want this game to be. The higher the value, the more good at your graphics, and so on. So to be honest, the app delegate it's kind of like it's kind of like the very beginning or the enter point, the real enter point. It controls how you create the window. Then we go to the resources. Every game will have at least a few resources. That's what we have seen in the previous video. They got a lot of pictures, PNG file. Scene graph. A scene graph is a data structure that arranges a graphical scene. A scene graph contains node objects in a tree. Yes, it is called a scene graph, but it is actually represented by a tree structure. This is what the tree structure looks like. At the top, it is a road, and it goes down by split it to two. It sounds and looks complicated. I'm sure you are asking me why should you care about this technique details. Because it is very important. Once you start adding node, sprite, and animation objects to your game, you want to make sure you are drawing the scenes you expected. But what if you are not? What if your sprite objects are hidden in the background and you want them to be the frontmost objects? No big deal. Just take a step back and run through the scene graph on piece of paper, and I bet you find your mistake easily. What? Since the scene graph is a tree, you can walk the tree. Cocos2d-x uses the in-order walk algorithm, and in-order walk is the left side of the tree being walked, then the road node, then the right side of the tree. Since the right side of the tree is rendered last, it is displayed first on the scene graph. So what does this mean? We go from the F to B to A to D to C. Oh, it's kind of a mess. I couldn't think it straight. But let's say this. What this other means is that on the left side, it will be rendered first. Then it goes the right side of those nodes. So in general condition, the right side nodes will be appear at the top of your game. Okay, let's look at some real example. Here it is a game. This example game scene would be rendered as a tree, simplified to the following. For example, we got the title, we got the label nodes, and we got the static nodes, walkway blocks. This is a blocks, and the horizontal line it is a walkway. Then we got the sprite nodes, which is 3 players, 1, 2, 3. And in the last, we got the manual node, start game. Another point to think about this elements with a negative z ordered are on the left side to the of the tree, while elements with the position Z order are on the right side. Okay, we can say something like this. First, we start with the label, then it is the background or the scores, then it comes the blocks and the working way, then it comes with 3 spirits or player. Finally, it got the menu. The scene on the left is actually made up of multiple node objects that are given a different Z order to make them stack on top of each other. The menu start games would be on the top, I think. So it's a child with the Z order of Z. We can do something like this. First we edit the title, then we edit the label, then we edit the spirit node. The last we add would appear to be the top of our game. It is a simple concept, but I don't know why he want to use so many words or description to describe it. They can just use this code to describe this, as I think. Then let's have a look at the spirits. All games have spirit objects, and you may or may not realize what they are. No, I realize what they are. They are characters. Spirits are important in all games. I know that. First, we can see how can we create it. We can use this command, spirit create, with an image file. Then this is how we can change the position of our spirit or characters. We can give a vector. A vector is actually an array or a list in Python. We give it the x and the y position, and we can somehow rotate it with a degree of number. Then we can set the scale. For example, we can make it bigger by giving it 2.0. Then we can, I don't know what this command would do. Anchor point, what is that? Let's illustrate each property. Okay, this is set the position 500. Yeah, as we can see, the x exercise, the character's x exercise is changed from something to 500, which is the center of the game. Then we can do a rotation by 40 degrees. It will become something like this. Then we can set the scales, and you would say the character gets bigger. Then we can somehow set the anchor points. I don't know what the anchor point is, but here you can say if we set it to 0, it will be at the left bottom corner of our character. If we set it to 0.5, it will be at the center of our character. And if we set it to 1, it will be at the right top corner of our character. So which means which means later if we use the set position method, the position would be the right point. Okay, I hope you understand that. Okay, let's go on. Then we go to the actions. Basically it got I don't know. Let's read this graph. No, read this parameter. No, paragraph. Okay, read this paragraph. Creating a scene and adding spirit objects on the screen is only part of what we need to do. For a game to be a game, we need to make things move. Yeah, we want to make those characters alive. That's why we need actions. So actions allow the transformation of node objects in the time space or in time sequence. For example, if we have to move a character. We have to do a rotation. We have to do a scale, and so on. Let's say, how can we light this spirit move? First, we create a spirit. Then we say move by what? Create 2 with the position. It seems like move a spirit 50 pixels to the right and 10 pixels to the top over 2 seconds. Okay, now you understand why they want to set this to 2, because it represents the time, 2 seconds. So we want to move this character at the X axis we add 50 pixels, and on the Y axis we add 10 pixels, and we do this movement within 2 seconds. So that's how we define an action. Then we have to run this action by using my spirit run action with the action that we just defined. Then here's another one. Auto move to create 2 with a vector of this. So this one, what is the difference between the move to and move by? If we use the move to, which means we want to move this object to a specific location, it's a specific location. It's not a relative move. It's an absolutely move. Okay, let's go on. Sequences and spawns. With moving spirit objects on the screen, we have everything we need to create our game, right? Not quite. What about running multiple actions? Yeah, that could be a problem. So Cocos 2D-X handles this too in a few different ways. Just like it sounds, a sequence is multiple action objects run in a specific order. Need to run the sequence in reverse? No problem. Cocos 2D-X handles this with no additional work. We just have to call some API. Take a look at the flow of an example sequence for moving a spirit gradually. Okay, gradually. Move, take an action and delay for some second, then take another action, delay for some second, and so on. Let's say this. First, we create a spirit. Then we define the first action, move to 1, which is something like this. Okay. Actually, we have defined 3 different actions. Then we create a delay. You can think of the delay also as an action, because it's an action. You do nothing in a period of time, right? So it's an action. We delay for 1 second, I guess. So in the end, we can create a sequence like this. Sequence create with action 1 delay, action 2 delay. But this delay has to be a new object. Which how can we do that? We can use say clone or just a clone function to create a new copy of delay variable. Then we do the third action, and in the end we give it a long pointer, which indicates the end of this sequence. And in the end, we give this sequence to the run action function, and that's how we create a sequence of actions. Good. This example runs a sequence in order, but what about running all the specified actions at the same time? Cocos 2D-X supports this too, and it is called spawn. Spawn will take all the specific action objects and execute them at the same time. Some might be longer than others, so they won't all finish at the same time. If this is the case, what does that mean? Some might be longer than others. so they won't all vanish at the same time. If this is the case, I have no idea about that, but let's have a look at this. First, we create a node. Why we would do that? No, we can think it as a spirit. I'll do that. Then we create 3 actions. Then we use the spawn create. We run the action 1, action 2, action 3, and the end of the action. We do this at the same time. Okay, at the same time. Why spawn actions? Is there ever a reason? Sure. What if your main character has multiple actions when obtaining a power-up? Maybe beating the boss at the end of a level has multiple actions that are needed to happen to end the level. Okay, it's basically how we run different actions at the same time. Or if you prefer, you could call it parallel actions execution or something like that. Then we goes to the next section, parent-child relationship. Cocos 2D-X uses a parent and child relationship. This means that properties and changes to the parent nodes will also apply to the child node. Consider a single spirit, and then a spirit that has children. What does that mean? With children, changing the rotation of the parent will also change the rotation of all children. So let us assume that the blue one it is the parent, and other characters on the top, they are children of that blue one. Then if we rotate the blue one, other character will also rotate. Good. And also if you change the scale of the parent one, which is a blue one, other character will also be scaled. But how can we create such a parent-child structure? They didn't tell you, right? They didn't tell you. And here it is a login stuff. It is very important for debug, I guess. So this is how you use it. You use log like a normal printf function. Okay. Let's have a look at the. No, we cannot take a look at anything. So this is today's tutorial. We just covered the basic usage or the basic concepts of how can we use the Cocos 2D-X to create our own 2D games. Yeah. So so far we just covered the 2D stuff. But that would be enough for a simple game. So before I go to the deep one or dive into this game engine, I would like to create some simple game first. But anyway, I'll see you in the next video. Bye.